Welcome to physics class. Tissue black atom, 70 kg object, rough surface. So that's our rough surface. Friction, and then we have 20 degrees angle. That's our 20 degrees. And then we have constant frictional force, which is 190 degrees. And then we have Newton, normal force, weight, and friction. So that's our friction. And what we have to do, we have to answer the question that said label the forces R, S, and T. So R is going to be our normal force, and S is going to be our weight, and T there is going to be our friction. So T is our frictional force. I'll give a reason why R is not does not work on the crate, because R is normal force. So because it's a normal force, it's a vertical force. So that's point one. R is a normal force, and also it cancels, so it cancels out weight. So the weight cancels itself. Okay, cancels out with weight, and then the other reason could be that it is a vertical component. So that's what it could be. The other reason, it's a vertical component. So the object is not moving vertically, it's moving horizontal on the surface, even though it's going under inclination. Now then we have information. Reaches point A with 2 meters per second, travel 12 meters. So we have velocity there at point A, which is 2 meters per second, and then distance traveled 12 meters. Then from there we are required to find, let us get the data first. So we're taking down as positive, so any answer that we calculate, find the positive value, that means it's going down. And now mass is 70 kg. And what else do we know? We also know that our angle of inclination there, it's 20 degrees. Okay, so we just collect all the information that will help us crack the problem. And then we have rough surface. Okay, so we have rough surface. So rough surface literally means that we have friction there. So friction is kinetic friction is 190 newtons, and then from there, what else do we know? We know that the motion is downwards, it's moving downwards. So we need to know the motion so that we can check angle, whether it's cos 0 or cos 180 degrees when calculating the force, the work done by the forces. And then what else do we know? We also know that the distance between A and B, that's AB, distance that is 12 meters. So AB is 12 meters. Alright, so we know that. And then from there we can go on and solve the problem. So we're required to find work net. So work net, we first need to know the force net, because the work net is related. So we know that the force going down there is Fg parallel. So that's Fg parallel going down. So it's for horizontal forces. Horizontal forces, we have Fg parallel and friction. So it's going to be Fg parallel minus friction to give us to give us the net force. So minus friction. So mg sine theta. So F net, force net, is going to be our mass is 70 multiplied by g, which is 9.8, and then sine of 20 degrees angle. Force we are already given, that is 190 newtons. So that's our force of friction. So force of friction is 190 newtons. So it's going to be 190. Okay, and then calculating that, we find that it is 44.63 newtons. Now we need to find the work net. So work net is going to be force net, okay, multiplied by the distance traveled horizontally, multiplied by cos alpha to distinguish between the inclination and the angle of direction. So that's going to be 44, and remember our force net is positive, so it's going to be 12 distance, and then our cos there is going to be 0, because same direction, or so force net is the same direction on which the object is moving. And then our final answer is going to be 535.56 joules. So that's our work net. So that's our answer for the top one. And the next we need to okay, this is step 1, step 2, and then step 3, okay, arriving us on the answer. And then we also have to go to the work net. So work net, there is going definition for the work energy theorem. So work net done on object on an object, okay, is equal or equivalent to the change, okay, so it's equal to the change the change in kinetic energy, okay, of that object. So its work net is the same as change in kinetic energy, okay, of the object, of that object, okay. So that's, you can put it in any grammar that you feel comfortable with, but for me this is how I'm going to literally translate the definition or define it. And then work energy theorem to calculate the problem. So we know that from our definition above 5.4, we have work net, change in kinetic energy. So our work net was already calculated on the previous problem, that is 535. So we have work net as 535.56 joule is equivalent to half. Our mass is 70 kgs, and then our final velocity is what we want to know at point B, squared minus our initial velocity was 2, so it's going to be 2 squared. So 2 squared gives us 4. Okay, so that's the equation for change net. Is half m minus f final squared minus bracket half m final velocity minus initial velocity in bracket. So we know that half of 70 is 35. Then we have to divide both sides by 25. So that's going to be 535.56 is equals to 35. And then bracket final velocity squared minus 2 squared is going to give us 4. So giving us 4, that leaves us with okay, so we're going to divide both sides. 535.56 all over 35, okay, all over 35 is equals to minus 4, but literally it's not minus 4, it has to be positive. Remember that minus has to move from the left to the right, from the right to the left, making it positive. So all that is equals to velocity final, so that is gonna be 19, that's positive there, and then it's gonna be 19.302. so squaring that up, our final answer, because you need to solve for v final, so it's going to be a root of 19.302 is going to give us 4.4, 4.4. It's gonna be 4.4 meter per second, and that's our answer. um, I just want to remind you guys, I just want to thank you for watching, and please don't forget to follow